Welcome to another video. So today we have an exponential equation. 4 raised to power x is equals to 48. This is a type of an index equation where we are required to find the value of x. On the solution part, I know that 4 can be written as 2 squared. So replacing this here, I'm going to end up with 2 raised to power 2. Power x should be equals to 48. At this stage, the x is unknown. So I'm going to introduce the logs on both sides of the equation so that I end up with the log of 2 raised to 2 power x should be equals to the log of 48. So I'm going to take you through step by step up to the final solution. If you're watching us for the first time, kindly subscribe to this channel, comment, and share this video. So I'm going to divide all through, or the x can come down as x to the log of 2 power 2 is equals to the log of 48. Then I'm going to divide all through by the log of 2 power 2. Then I'm going to end up with now x is equals to the log of 48 divided by the log of 2 raised to power 2. Next step, I know that 48 can be written in terms of its factors, and this is just the same as 2 power 4 multiplied by 3 is giving me 48. So replacing this here, I'm going to end up with x is equals to the log of 2 power 4, which is 16, multiplied by 3 divided by the log of 2 power 2. Next step, you're going to recall again that wherever you have the log of a multiplied by b, this can be expanded as the log of a plus the log of b. We're just taking you through basic laws of indices or logarithms. So applying this law here, of course, I'm going to end up with x is equals to the log of 2 power 4 plus the log of 3. And then I'm going to divide all through by the log of 2 power 2. Next step, this 4 can come down so that x becomes 4 to the log of 2. And then I'm going to separate under a single denominator as 2 to the log of 2, of course, plus the log of 3, then divide by 2 to the log of 2. So it is easy to see that the log of 2 and the log of 2 is here. It's going to cancel. And then, of course, 4 and 2 gives me 2 when you divide, plus if you come to this at the end, it is easy to see that my equation will change to a half. Log 3 divided by log 2 if I separate it like that. But wherever you have that the log of a divided by the log of b, then this can be re-expressed as the log of a to the base of b. So rewriting this under a single log, then the equation now going to change to x is equals to 2 plus a half then the base can come up as the log of 3 to the base of 2 as the required solution for x for that particular equation. I'm going to go ahead and verify if x is indeed 2 plus a half to the log of 3 base 2 for a number given 4 raised to x should give me 48. But wherever I have x, I'm going to replace the whole of this so that it becomes it gives me 4 in bracket 2 plus a half to the log of 3 base 2 should give me 48. I'm going to separate this, the upper part. Recall that wherever you have a raised to m plus n, then this can be expressed as a raised to m multiplied by a raised to n when I separate it. So applying that here, it's gonna be 4 raised to 2 multiplied by 4 raised to a half to the log of 3 base 2 is equals to 48. The next step, I know that 4 raised to 2 is of course 16 multiplied by this 4. I'm going to write it as 2 to the power 2 then multiply by power half to the log of 3 base 2. Want to see if it's gonna give us 48. It is clearly easy to see that the 2 and the 2 can cancel, and then I'm gonna have 16 multiplied by 2 to the power of log 3 to the base 2 should give me 48. But recall that again, that wherever you have the base a raised to a log of maybe b to the base a, you realize the base and the base are same, and that automatically changes to b. So applying this again here, I'm gonna have the 2 and the 2 gonna cancel, and then all of this remains as 3. So I'm end up with 16 multiplied by 3 is equals to 48. And indeed, my left hand side, 16 times 3 is 48, should be equals to my right hand side, 48, which is the proof for our equation 4 raised to x is equals to 48. And of course, that gives us the answer. So we have come to the end of this particular tutorial. Kindly don't forget to subscribe to this channel. Watch our playlist. We have a series of similar equations. Share this video. Leave a comment with an alternative approach. And most importantly, subscribe as you turn your notification on. So until we meet again in the next video, goodbye for now.